Good morning to one and all. On behalf of Rameswaram Institute of Technology, I welcome you all for Analog Electronics Laboratory session. In this session, we are going to discuss about how to generate a square wave using BJT multivibrators. In this multivibrators, we going to discuss about astable multivibrator. Equipments and components required for this experiment: transistor either BC548 or BC107, 2 numbers; resistor 2 kilo ohms and 100 kilo ohms each, 2 numbers; capacitor 0.1 microfarad, 2 number; cathode ray oscilloscope 1; DC regulated power supply 0 to 30 volt 1; probe, connecting probe 2, and wires, connecting wires. This is a circuit diagram of astable multivibrator, cross coupled astable multivibrator. Q1 and Q2 is an NPN transistors, and the collector side resistance RC connected as an 2 kilo ohms, and resistance, cross coupled resistance R connected as an 100 kilo ohms, and cross coupled connection charge capacitance C1 C2 is 0.01 microfarad. C1 responsible for turn on the Q1 and C2 responsible for turn on the Q2. The value of RC and C1, value of R2 and C2 for the time constant. This is a model graph. VC1 and VC2 for collector voltage for Q1, collector voltage for Q2. We can take output from either Q1 or output as in from either Q2, and the VB1 and VB2 are the base biasing voltage. This is a biasing voltage supplied by the capacitor, while the charging and discharging of the capacitor voltage is applied as an base biasing voltage, is an V on. When reaches the V on, either Q1 base VB1 is reaches to Q1 V on, then Q1 is turned on. VB2, the VB2 reaches V on, then transistor Q2 will be in a on condition. This way, with the astable multivibrator, output will be generated. This is an circuit connections given here. A BC547 transistors we are considered. The first transistor connected in the basis of emitter base collector, and second transistor connected as an collector base emitter. The power supplies are connected. Dual power supply or single power supply is used. Positive connections are given upper side, and negative connections are given bottom of the breadboard, and the wires are taken for the output. The power supply is switched on now. Or initial testing 0 position is kept, and then the connections, the base connection, either collector side connection is taken for the analysis, and then ceramic capacitors, 0.01 ceramic capacitors are connected, and 4 resistance are the RC1, and for collector side this is an RB internal base resistance RB1, RB2, and then for collector side resistance, and then for these connections are CR connected within CRO through CRO probe. Leads are taken. This is a cathode ray oscilloscope, 20 MHz cathode ray oscilloscope. This is one. While switch on the CRO, we check for the center access line. This is a 30 MHz oscilloscope used in our laboratory. This is a dual power supply, digital dual power supply is here. Now we supply the voltage, DC voltage for 4.1 volt. The output of the base side, that is in capacitor charging voltage, is displayed here for small amount of 4.5 voltage, and by varying the volt per divisions and time per divisions we can get a clear waveform. This is an base voltage for transistor Q1, base voltage for transistor Q1. Now we supplied as an 6.5 volt for that. This particular waveform is taken through the CRO probe. Now voltage is reduced almost for astable multivibrator we need a 5 volt in a DC 5 volt, almost 5 volts, so that we connected here. So now here connections is removed and it is connected to collector side current transistor Q1. Now we get a square wave as an output, that is state changes from 0 to 1. So initial state is 1 to 0 and 0 to 1. Now we can remove and it is connected to base side current transistor Q1 for our purpose, for measuring purpose. This is an base side connections. So capacitor charging and discharging voltage is shown. Now we connected with an next transistor collector side, that is an Q2 collector side. We get a square wave 0 to 1 is in starting position. The output square waves are shown here. This is collector side voltage. And we connected for base side, that is in capacitor voltage, capacitor charging and discharging voltage. So this is in VB2 voltage, ramp voltage. We get as an output, again it is connected with an position. We can also design with an output can be measured with the help of LEDs. Here the small changes is capacitance are replaced as an 10 microfarad capacitance is connected here for a charging and discharging. Based on that the LED is blinking. Thank you.